Good morning, dear students. In this video lecture, I am going to discuss the preparation of alkene by dehydrohalogenation, or you can say beta-elimination reaction. So let us write dehydrohalogenation. So alkyl halides having a beta hydrogen, when heated with alcoholic potash, that is KOH, dissolved in ethyl alcohol. So alkyl halides having a beta hydrogen when heated with alcoholic potash, that is your KOH, dissolved in ethyl alcohol. Then removal of HX, that is your hydrogen halide, will occur, which is referred as beta-elimination reaction, or you may say it is your dehydrohalogenation, which is referred as beta-elimination reaction, and the product form is an alkene. The product form is an alkene. Now let us see this dehydrogenation or beta-elimination. Now the question is, why it is your dehydrohalogenation? Why it is your beta-elimination? So these are the important questions related to this reaction. Now, for example, if we write an alkyl halide of the chain CH3 CH2 Br, this is your bromoethane. Now this bromine is halogen. When it is heated with your alcoholic KOH, delta stands for heat. Alcoholic KOH means we dissolve KOH in ethyl alcohol. So what happens in this case? Bromine is eliminated from this carbon, while hydrogen is eliminated from this carbon. So we have removal of HBr, and then your product is CH2 double bond CH2, that is called ethene. Now this carbon, which is denoted by a streak mark, this carbon is your beta carbon. This carbon is beta carbon. However, this carbon is your alpha carbon. So if bromine is on alpha position, then this is the hydrogen which is present on your beta carbon. So the hydrogen present on beta carbon is referred as beta hydrogen. So we can say, as your hydrogen removed from beta carbon, so the elimination is known as beta elimination. Second point, there is removal of hydrogen bromide, that is hydrogen halide, hence it is known as your dehydrohalogenation. For example, if we consider some higher alkyl halide, if we consider alkyl halide like CH3, CH2, CH2Br, say this is your 1-bromopropane. This is 1-bromopropane. Now if we heat with short ALC means alcoholic KOH, then this is the removal of your HBr, because this carbon is referred as alpha while this carbon is referred as your beta carbon. ये जो कार्बन आप देख रहे हो ये आपका बीटा कार्बन कहलाएगा, and then it will be CH3CH double bond CH2, that is again your propene. But if we consider 2-bromopropane, if this bromine is on, suppose second carbon, if bromine is on second carbon, say CH, Br, CH3, this compound is your 2-bromopropane. Now if we heat with alcoholic KOH, again delta for heat, now what will happen? This is bromine, so this bromine will eliminated, while hydrogen will be eliminated from your beta carbon. Now in this case, this carbon is also beta carbon and this carbon is also beta carbon, because this carbon is alpha, then this will be your beta, again this will be beta. तो दोनों बीटा में से किसी भी बीटा से अगर आप हाइड्रोजन एलिमिनेट करते हो, then the product is same, like CH3CH double bond CH2, or the product may be, suppose from here if we remove hydrogen, then we can say it is CH2CH CH3. So both compound is simply your propene. So no question, if we have either 1-bromopropane or 2-bromopropane, they will give the same type of alkene during your beta elimination reaction. Now the question is, we have different type of halogen atom. Suppose that halogen is your chlorine, that halogen may be bromine, and that halogen may be iodine. So which of the alkyl halide will undergo this reaction in a faster way, and which of the alkyl halide will undergo in the reaction in a slower way? You can write the rate of beta elimination, the rate of beta elimination or dehydrohalogenation is as follows: Ri greater than Rbr greater than RCl, means iodoalkane more reactive than your bromoalkane more reactive than your chloroalkane. Suppose somebody asks you that we have three different compounds like ethyl chloride, ethyl bromide and ethyl iodide. ठीक है? If somebody asks you, we have ethyl chloride, ethyl bromide and ethyl iodide. If all these three compounds, when heated with alcoholic KOH, then the product is your ethene. No doubt, the product is your ethene along with, if ethyl chloride, then it will remove HCl, ethyl bromide, then HBr, and ethyl iodide, then HI. But which will give product in a faster rate, यानी किस केस में ये इथीन जो है वो जल्दी बनेगा? Then the answer is in case of your ethyl iodide. जबकि सबसे स्लो रिएक्शन किस केस में होगा आपका? That will be in your ethyl chloride. Now let us suppose if we have a haloalkane, or you can say alkyl halide of this type. For example, CH3, CH2, CH2Br. If we heat with alcoholic potash, that is your KOH. Now, this carbon is alpha, this carbon is beta. So, hydrogen is removed from beta carbon. Then your product is CH double bond CH2, that is your but1e. तो प्रोडक्ट आपका बन जाएगा but1e. But let us suppose if we have a alkyl halide of this type, this is your 2-bromo-butane, और तब आप इसको हीट करते हो अल्कोहलिक KOH से. So this is bromine, this carbon is alpha, but this carbon is also beta and this carbon is also beta. क्योंकि बीटा कार्बन जो है, हैलोजन जिस कार्बन पे है उसके ठीक बगल वाला कार्बन बीटा है, तो ये भी बीटा हो सकता है, ये भी बीटा होगा, ये नहीं होगा. Now we have two different products. Suppose if hydrogen is removed from this beta, इससे अगर निकलता है, then the product is CH3CH2 CH double bond CH2. और अगर इस बीटा से आपका हाइड्रोजन निकलता है, then the product is CH3CH double bond CH2. CH3. Now this compound is your but2e, while this compound is your but1e. Now the question is, in this case both but1e and both but2e are obtained. दोनों बनता है, लेकिन क्या ये 50-50% बनता है? The answer is no. For your information, the yield is near about 80% of but2e and the yield is near about 20% of but1e. The detail you will study in class 12, not in class 11. If more than one alkene is obtained, if more than one alkene is obtained during the beta elimination reaction, if more than one alkene is obtained during the beta elimination reaction, then the more alkylated alkene, formed will be the major product. So naturally your less alkylated alkene form will be minor. It is referred as the Zaitsev rule of elimination. It is your Zaitsev rule of elimination. So the detail of Zaitsev rule of elimination you will study in class 12. Now if somebody asks you why the more alkylated alkene is your major product, you can see it has more hyperconjugative structure. If you compare the stability of but1ene and but2ene, अगर कोई पूछे कि भाई but1ene और but2ene में ये 80% प्रोडक्ट बना तो क्यों बना? The reason is because this is more alkylated, this is more stable. It has more number of hyperconjugative structure while it has less number of hyperconjugative structure. So you will study detail in class 12. In 11, the detail is not given in your particularly NCERT textbook. So I hope it is clear that how we can prepare alkene from alkyl halide.